Hello, my name is Chris. I'm with ArboDesigns. I'm the author of the 3D-box-builder, and I contemplated whether to create some sort of written documentation for this, or just thought it would be easier to do some sort of video where I can go through each of these steps. And I think the viewers will learn more just by watching me, and I can point out different things about the application and how it's used. So to start off, let's go ahead and you open up a browser so you can. I've tested this in Chrome, Safari, and Edge, so it should work in those, and also Firefox I would assume works. So what you want to do first is go to the OpenJS CAD site. So openjscad.xyz, and once you're there, you are going to take the file that was you purchased and downloaded, wherever that is, and it's going to come in a zip file. So what you want to do is unzip it. So in my case, I'm on a Mac, so I will just go ahead and double click on that. It will open it up, and you will see a JavaScript file. So this is the actual utility, that's the 3D box builder utility that will be shown once I drag it into this JSCAD environment. So a JSCAD environment is it's an open source project, and you can learn more about it. We can I'll show you some links to it, but it is totally open source, and feel free to learn more about it. But anyways, to get started with this, with the box builder, what you want to do is to grab the file and to drag and just drop it right into the environment. And it will come up with a generic box with some predefined parameters. So over here are all the parameters associated with the box builder. And you can close these, call these groups. Sometimes it'll help if you minimize a few of these just to clean up things a little bit. But so once you do that, you want to scroll down. Okay, let me open this all the way up. This is what you would typically see with all these expanded. Is once you drop the file in there, you'll see the box. But it's important you come down here to this instant update, so that as you're changing any of these parameters, that this particular CAD model will update dynamically as you're working. Otherwise, you'd have to come over here and hit up. You would change a parameter and hit update. So I'm going to go ahead and minimize these groups, and what we can do is I'll just go through each of these group types. I'll show you some examples of what's going on. So the 3D box builder, the intent of this was to allow for a 3D modeling environment, so that you can see what you got before you actually export the 2D representation. So the ultimate goal here is to do some what we'll call indirect modeling by changing parameters here, which will reflect the changes over here. The changes here will also update over here. So it gives you I like this idea of having the 3D model because I can see what's going on. There are, of course, other utilities out on the web that do this sort of thing already, where you just put in parameters. It gives you a 2D representation. This will help you, or help me, it gives you the advantage of you can design it, see the whole model, twist it around, look up and down, and before you actually export it out to put it into your laser or CNC. So also with this, I've incorporated both laser cutter engravers, so when you export it'll work with those tools. It also, something that's unique, you don't see a lot of it out there, is I put a lot of work into trying to get this to export it to where it will work on a CNC, and a lot of that work has to do with these dog bones. Pretty tricky programming to get those to work. So I wanted to make this universal to be allowed to work on either one of those tools, whichever one. So I can demonstrate all that one. So as I move through this, so let's talk about a little bit about the common group here. So we cram into all the everything that's going on with these parameters, but you can work in inches and millimeters. So by default, this is designed around inches. So I know there's a lot of people that probably use millimeters, and you can certainly switch it over to millimeters, but be careful with, you just have to know, not be careful, but you have to know that when you switch it over, everything, all of these values here will be representative of what the inches were. Those aren't not going to update or auto calculate into millimeters. They don't have that capability within the script. So the script that I'm talking about will show up over here. This is the box builder JS file that that was shown earlier. This is condensed and encrypted, so you will not be able to edit it, but that is what's going on with this. It's a scripting environment that I have limited control over, so I can't control a lot of the things that are in this JSCAD environment. I can't programmatically change some of these things, so I can't modify these on the fly. So anyway, so that's a limitation of this, but you can still go to, if you go to millimeters, go ahead and go through each of these and make sure these numbers represent something that's within that units, within those units that make sense. Otherwise, you're going to get some really weird results over here that aren't going to make sense. But once you do get it set up in millimeters, JSCAD, this environment, if you use the same browser, it saves information locally, so that when you open up, if you close this tab and open it up again, it'll load the last file that you had, the last project that you were working on. So that helps. So it will come up in millimeters and you don't have to reset this. Now if you go out to another browser for the first time, it'll come up as inches. You'll have to go through each of these and change any of these that makes sense. But just have to be aware of that. You can use, of course, you can use inches or millimeters, and I do some conversions within my script to handle that scenario. So, but I cannot update these and change these. These are set for inches, but if you want to, you can go ahead and go through each of those, and once you have those set, then you should be good to go. So I'm going to leave this in inches, and you can see how it, when it flipped over, it rescaled everything. So that's talking about units, and the next is measurements. So you can, your measurements here, this is your width, depth, and height. So the width is what I'm calling right along the front here. That's the width. The depth is your y-axis, width is x, and your z-axis is height. So that's kind of what those particular designators mean. And getting back to this, the measurements are taken. So when you're building this, these measurements represent. So the width is 4, so it's 4 inches outside to outside here, and depth is from here 6 inches. So you can also do inside measurements, which is extremely helpful if you're doing some boxes inside of other boxes. It's super handy. So what you're saying is the measurements, this 4 inches represents inside, so it'd be from this edge, the inside of the box here, so you take away the thickness of the box. So this will come in handy. I'll show some pictures of some boxes that I did, some sleeve boxes, and also drawers. Those sort of things will be very helpful if you create a box, an inner box and an outer box, it's really simple. You add a little tolerance and you can slide one box inside of another. So having this inside and outside is very helpful. And material thickness, I've got this set up for 1/8 of an inch, and that's typical for laser cutter, mostly what I use. But you can certainly, say if you're on a CNC, you're probably going to want something thicker, like 0.5 inches. And you can see how that reflects over here. You get much thicker material. And going down here, if you want to turn off finger joints, you can just have just straight sides with no finger joints on them, depending on what your use case is. I typically leave that as yes. And over here you can dynamically, these are your finger joints here. You can dynamically change those. Let's see, so let's look at our width side. This is 1, 2, 3. I could go ahead and I can decrease that, give me 2. And this is just all by eye. A lot of times some people like to have a lot of these, almost looks like stitches. Other people may not want that many. So like for the height, you could bring that down to even 1. Or the depth, you could even do 1 if you wanted to. So that's what that is. All right, the next group that I'd like to talk about is this lid here. So let's go ahead and open that up. And let's go ahead and put the material thickness back to 1/8 of an inch. And it looks good. We might be able to, let's put some finger notches back in here. And that look a little bit better. So over here, let's talk a little bit about navigation here. Of course, you can rotate this just by taking the left mouse button, holding it down. If you want to pan, you can hold the shift key down and drag it. And that sometimes comes in handy when you want to move the angle a little bit. Sometimes it gets kind of strange, and so it gives you a little extra motion. So that's it. A couple other, there are keyboard shortcuts. So if you go over to, let's go to configuration, there are some hotkeys. Now the front and back are reversed from how I have this programmed, and I just be aware of it. So I'll point out how I have it set up in my program. But the common ones you will use is you hit the T for top, and it'll give you a top-down view. You can do left view L, right view, and then the front and back are reversed, so you're going to have to hit the B key to get the front. And I think it's more of the JSCAD has those backwards from what I can tell based on how I program the XY axis. So just be aware of that those are reversed, or you can come over here and change those if you'd like. A nice feature to this is I will switch between light and dark, but they have a whole bunch of other themes. My favorite, light and dark. And you can switch that over. And I guess while I'm clicking on this here, you can pull up some information about the JSCAD, talk about user guides, and over here there's a little bit of, there are some example scripts of how to do certain objects, and you can learn more about how to do your own programming like what I did here. So I wanted to introduce that to you. Okay, so get back to the lid. So I've included a couple different lid types here just to make it a little more versatile. Here is none, obviously. If you want to put a lid on top of it that's totally enclosed, I guess there could be a use case for that. I don't know, but I just thought came as default, thought I'd leave it. And the other one I thought would be nice, spent a lot of time working on this, is the hinge. So you can create a hinged box. So here you go. I can go ahead and look at the left side of the box, and you can see here that this lid will pivot right there on this point here. So that's pretty handy. I've seen a lot of boxes that people are selling as far as plans on Etsy, and I saw, well, it'd be nice to have this feature as well. So that's what the hinge type box is. And so you got the 3 type, none, finger joint, and also the hinge type. And there's another parameter here. Let's look at the top down. It is the hid lid tolerance. So 0.065, so that's approximately a 1/16 of an inch. So that's pretty well. You can see here, this is why I like the 3D. So if you kind of move it around and you zoom in, you can see the actual gap. So that's what the tolerance is. It's this gap all the way around. And of course you don't want it snug right against the sides, otherwise it's going to hang as you're flipping it up and down. So, and you can also get a pretty good representation there of what it looks like. Now, something to be aware of, this is only with the CNC. If you're doing laser, this doesn't have to be, 0.65, it could be 0.02 or something like that. Laser is going to be much more accurate and it's going to be straight. If you're doing this with the CNC, just be aware that you're gonna, if you're cutting, I would use 1/8 of an inch end mill, that it's not, you're gonna have a little radius here when it's coming around. As the cutter comes here, it's gonna cut like this on the outside, so you're gonna leave a radius. So I set this 0.065 would probably work fine for a tolerance if you're using an 1/8 inch end mill. But so you got to be aware of this with this lid only, so you don't waste material or time, but just have to think about that with the CNC. With laser, this is not a big deal. It just cuts and you're pretty close except for the kerf. So keep that in mind, and that's why this is pretty wide. For laser, I might go 0.02 for tolerance, and it tightens that up, just looks better. And you can see I got a little gap, that should be fine. Yeah, so those are some options there. And there's another, the hinge lid hole tolerance, and that is this hole right here. So you can zoom in on that. You can actually, you could leave it at 0. I've had pretty good success at 0 just with the laser cutter. But if you wanted to say it was rubbing or it's too stiff, you could actually put in a value there. It'll make that hole a little bit larger. So it's up to you. It's something that you would have to mess with to figure out what works for you. Okay, so I'll just put that back to 0. Don't have to worry about that for now. And okay, so then there's some parameters for the, if you have the hinge type. I'm calling this a finger tab. So if you're going to lift this with your finger, that's what this particular, and I'll hit the B key and pan it over. So this is what I'm calling the finger tab. So you can change the width of it and also the length of it. If you want it to protrude out further, you could do that. So the length of it, it's just 1%, and you'll get a feel for the units here, but that's all it's doing, is you can extend it in and out, and also the width as well. You can increase the width, decrease the width. It just gives you more options, so when you're designing this. All right, the next group that I'd like to discuss, I will minimize the lid, is the laser. So this is specific to the laser cutter. And something to note here, so question will come up, well, I'm working with the laser, but what if I'm working with the CNC? You know, what parameters are active and not active for laser versus CNC. The the difference here is, or how you would know this, is if you kick on the dog bones, then the CNC parameters will be active and it will disregard the laser parameters. Well, except for the overhang, but it will not apply the laser kerf, but it will do the overhang. So anyways, I just want to point that out. If you're going to be working the CNC, kick on the dog bones, and then you'll be working in the CNC environment. But if not, the laser parameters will be active, and specifically the kerf. So you'll have to. I think most of you that use lasers, you understand what kerf is. You will have to run a separate test with each material type to understand what your specific kerf is. So you could put in my case with this material, I could put a 0.007 would work well, so that when I export this to a 2D, it will apply the kerf to the cuts. So that's what the kerf is. I think most people that have worked with this understand that. And this tab overhang, this was something that I added. I haven't used it much. I thought, oh, it'd be kind of nice. If you look at after it cuts, it leaves these burn edges. So you see the light, dark, you know, on these edges. So if you wanted to, you could put in an overhang, and I wouldn't go that far with it, but what that would allow you to do is you could sand that off. Say if you didn't like the dark light, you wanted the color to be more consistent, you could go ahead and put in a little bit of overhang, and then take your sander, when you assemble it, take your sander and just sand that all off. It'll make it look more consistent as far as the color, and the finger joints are not as pronounced. So that's an option. So all kinds of little, I encourage folks, and I think most of you will, is when you're in here, you're just going to start playing with it. That's the way to learn this. Just start changing values, and the nice thing is you will have this model and you'll see it update dynamically on the fly, and you'll know, oh, I can see what that does. So that is the laser group. Okay, the next group that I'd like to talk about is the CNC group here. So yeah, if you want to export your model out 2D to throw it on your CNC, here are the parameters that you'll have to play with. So first thing, let's go ahead and increase the thickness to something that you might actually run on your CNC. So 1/2 inch is a good thickness for the material. Let's turn off let's get rid of the lid. Okay, so here's a good starting point. So to kick it into the CNC mode, you want to turn on your dog bones. And once your dog bones are turned on, then these will be applicable to your model. So I'm going to so as far as the dog bones, let's take a look at those first. Down here you got your dog bone types. So I'm going to look at the front face, and I'm going to hold what I need to do is pan this down. So I'm going to hold the shift key, and I'm going to drag down with my mouse so I can get a better view of these dog bones. So we have 4 different types of dog bone or dog bone styles. So the default is this min, and it'll probably be the one that you primarily use, one I just typically use, but I did include a few others. So obviously you need the dog bones to add corner relief, so that just because of the end mill will leave a radius, and you won't leave a radius here. It can't cut at 90 degrees. So these dog bones will provide relief so you can get a tight fit on your finger joints. So you have the min, the max, and these were the typical ones that years ago that a lot of folks had used, and I left it in there. If you want to use those, you can. These are the T slots. This is another style that is used, and the last one is an X min. So it's similar to just the min, but it removes less material here, and then you may have to just pound it in a little bit, but you get a cleaner fit, and you don't have a lot of these gaps here, or these holes, that as far as a visual appearance. So play with it. Some of these I've used, others I haven't. I just included them in this design as a property. So those are the 4 different dog bone types. This fit clearance. So if, let's say, you go ahead and you cut these finger joints on your CNC, and they just won't fit in there, they're too tight or they're too loose, this will allow you to this value will allow you to tighten that up or loosen it. The larger the number, the looser the fit. So if I go say 0.01, then you can see how that opens up, and you can also go minus 0.01, and it's hard to see that, but as I move this around, you can see a little bit of the artifact here. So it will apply it to that. So if you have an issue with your, as machines get older, you got hysteresis or some sort of a mechanical wear or sloppiness, you can control some of the fit with the finger joints using this parameter here. And as far as the end mill diameter will be important when it comes to the dog bones that you're doing here. So most of the stuff I do, I just use this 1/8 inch end mill. So let's say you had a 0.25, a 1/4 inch end mill, it will make these larger dog bones. So yeah, you can plan accordingly if you want to use a large. I don't see why you'd want to, but if you had to, you could use a larger end mill. But this end mill size will affect obviously this dog bone relief here. So I typically use 0.125, or if you're using metric, you're probably going to use 3mm for that. So those are the few parameters that you have when working with the CNC. Hopefully that'll get you what you need in most cases. I don't know of too many generators that are out on the internet that provide this level of support for the dog bones, but I may be wrong. But anyways, I start off with I do a lot of laser cutting, but I also have a CNC, and I wanted to make these boxes, so I spent the time trying to implement these in my script. Pretty complicated to get all this stuff laid out, but I think it's going to be super handy when I need to make some beefier boxes, something a little more strength to them. So anyways, that's the CNC. All right, moving on to the next group. So this next group I've titled finger pole / notch. So what are finger poles, or what am I calling a finger pole? So let's go ahead and let's put the material thickness back to 0.125. And let's turn off the dog bones. All right. And let's go ahead and turn on finger pulls. So that's what I'm calling a finger pull. It's almost like a drawer pull looking thing. So, and that was primarily my idea I had with it. With this was if this was inserted as an insert inside of another box, then it would look something like a drawer. So you could, slide this into something and then be able to stick your finger in the slot if it's large enough. So that's what I'm calling a finger pull. So you have some parameters here. You can change the location of where these are located, and you can put them on this is the front, back, left, right, front, back, front and back, left and right, front, back, left, right. So you could put these on all of the sides if you wanted to, if that was something you want to do. You can change how wide, as far as a percentage, how wide you want that notch to be. Maybe you want it like that, and then maybe you want it to also the height, so you can go ahead and add those. So primarily I've been using just this front, and then I'll create a second box and go ahead and enclose it and create an outer box where this inner box could slide inside of it as a little sleeve box. So there's all kinds of little ideas. I will share some of those pictures of boxes, and lots of different ways you can be creative with this. But anyways, that's what the finger pull is. Just a little extra, another parameter for just being a little more creative with how you design your boxes, give you a little more options. All right, moving on to the next group, dividers. So this was a feature that I wanted to add to my boxes that I added last, but it's been really nice and useful for adding some separation inside the box. And I've seen some plans on Etsy that came with these sort of dividers inside. So anyways, I've implemented the dividers. So to turn those on, hit select yes to those, and I'm going to turn off the finger pull. Okay, so you can see the divider sitting inside of the box. Hit the T key to get a top-down view, and I'm going to hold the shift, and I'm going to drag with my mouse to pan it to the right, and use the scroll wheel to zoom out a little bit. So the dividers are set up. We have two parameters here. We have rows, which are the horizontal. Got row 1, row 2, and your verticals are your columns 1 and 2. So you can add more rows, add more columns, and you'll have this. So this is super handy to have. So let's see, some other parameters we have is, okay, let's go back in the top view. If you ever wanted to, this side tolerance, if you don't want it real tight on this side, on any of these points here inside the box, all of these here, you can add a little bit of a tolerance. That's what that is. So 0.01, then you can see that it leaves a little gap there. You can see a little gap down here. So that's what the tolerance is right there. You can see it there. If I take that out, so this is why it's super nice to have a 3D model. You really get to see, because once you look at the 2D view, it's hard to see these sort of things or how these components are interconnected. So that was the tolerance. Another parameter that I added is maybe you don't want these dividers as far as the height. Maybe you don't want these to go all the way to the top. So I added this top margin percentage. So if you wanted to shove that, have a little bit of a margin at the top, you can start increasing this, and that will shove those down. Okay. And then if you wanted to, I guess you can see how these are made is if you added, this is just a visual effect. It allows you to separate, to actually split apart to where you can see how those are made. They're just split down the middle, and then they're just interconnected. Just super simple. And when you assemble this, you can slap those together, and then I'll just put some glue here on the edges to kind of hold them in place. So, like I say, this 3D layout is just to do a blow, just to blow it apart, so you can kind of visualize it a little bit. And that's about it for the dividers. All right, well, let's talk about this last group, and this is really what it's all about here. This is kind of the end of the road here, but this is ultimately where we'll spend a lot of our time here, is at the view and the export. So right here, so we are in 3D view. That's what this represents. This is 3D view. Now when I kick it into 2D, this is going to be our final product. This is what's going to be exported out to the laser cutter or out to an SVG or DXF, and then we can import that into a CNC or laser cutter. So when I'm in 2D mode like this, like I say, you can double click it to get everything to zoom out, and then it will be skewed like this, but once again, hit the T for top view, hit the T key, and then you can zoom in and out or pan, hold the shift key and pan it around. So now you can see the 2D representation of what was going on here. And switching back, you have hit the T key, have your bottom, you got your side here, you got your left, your right, your back, your front, side, and up here are your dividers. You got your row and columns. So everything is included right here. So at this point, what I primarily do, you have the option to export up here. There's different outputs you can do. I always use SVG, but you can try DXF, but SVG has been working fine for me. I'd recommend that. So just hit SVG, you can hit export, and you can bring it up. So there's your SVG, and then you can double click it. I use Affinity Designer. You can use Illustrator, whatever you like. And yeah, here you go. And now you have your SVG. So ultimately that's what you want to do. In the end, after you do all your design, you're going to come in here, export it out, and then go ahead and cut it. And the other option here is while you're in the 2D, so I got 2D layout separation, you can step it in or out. So this is the separation in between each of those parts. So depending on what you want to look at, sometimes you want to step it in and you can see what's going on with. You'll see that when you mess with, let's say we go to the laser and we add a kerf of 0.007. Then you can come in come in here and you can see that kerf applied. You can see that there is a little bit of tolerance on either side, so it accommodates for the laser curve. So you may not use this much, so I was using it for early development, but anyways, that's what that is. And let's go back to 3D. And another useful feature here that I used quite a bit when I was developing so I could see what's going on with all these components is you can toggle the view on and off. So if I wanted to hide the front or the right side, I could do that. And also there is this 3D layout separation. So if I wanted to blow these components apart like this, just to get a better view of what's going on, I can do that. And then I can turn off certain components, certain sides. And then I can also come up with my divider and I can blow that apart too. So now you can see all of these components working together. If I turn on, let's turn on the dog bones. And you can see the dog bones are even here on these dividers. So anyways, that's pretty much it. I think it's just something that you'll have to start building. You'll have to start making and seeing where your limitations are. Unfortunately, we don't have, so like I mentioned earlier, if you close this out and then you come back in, you drag in, drop your JavaScript file, your box builder file back onto here, it will open the parameters that you last used over here. So I don't have currently anything set up, a mechanism to save these parameters and name them something and come back. I may end up building some sort of a Chrome extension that may do that. It's just, like I said, the way this JSCAD is set up, you're limited on what you can do via your scripting and how you control the main environment. So this may require some sort of an external application to do that. But if that becomes available, I'll let everyone know. So I think that's mostly it. If you have any questions, send me an email. Yeah, if you have any problems or you find some strange bug, let me know so we can work through that and let's go from there. All right, thank you. All right, one more item I'd like to discuss, something that I built into this. As I mentioned earlier, there are some limitations to what I can do and how I can interact with this JSCAD environment that I'm working within. So while I'm developing this, I had questions such as, what are the cell size here? If say I have something like a small jar that I want to put inside these dividers, and I know that the size of this jar, but as I'm designing this, just how big are each of these cells? So I've built something into the console log, or I'll show you, this is built into the developer tools to output some of these dimensions so you have an understanding of some of these dimensions that before you actually export them out. So anyways, let's go ahead and let's put everything back together here. Put that together, and so if you want to know what the size of each of these individual cells are, what you can do is you'll have to turn on the developer tools, or you have to look at the Java console. So I'm here within Chrome, so I can go to View Developer JavaScript Console, and there are some outputs here that I've printed. And one of those is this divider cell dimensions by width, depth, and height. So this is in inches, so 1.2 inches by 2.5. So you have 1.2 by 2.5 by 1.2 inches tall. So that would be, each of those would be those particular dimensions. So that's handy if you want to, if that's something you want to know before you export. You could certainly export out 2D and then measure it in Illustrator or something like that. It may be a little more difficult, but anyways, if you want to use this, you can. And I've also included, I also had a need to know when I turn on the finger poles, just how big those finger poles are as far as the width, 0.62 by the height. And that was more important for if I wanted to stick my finger in there. You're going to need at least, a 1/2 inch or so to be able to get your finger into that opening there to be able to pull it out like a drawer. So anyways, that's available to you if you want to remember to turn that on. If not, you can certainly export it out and look at it as a SVG, and in your using Inkscape or Illustrator or whatever your SVG editor is, you can certainly measure those dimensions. These are just helpful little utilities that might be helpful to you. All right, thank you.